Good morning to all of you. Myself Dr. Neha Desai, Assistant Professor in Department of Chemistry, RBNB College, Srirampur. In the last lecture, we are discussing about the ion exchange chromatography. In the ion exchange chromatography, we have discussed about how the influence of a mobile phase on an ion exchange. Then we have also discussed about the different types of ion exchanger, that is the cation exchanger and the anion exchanger, along with the types of the ion exchange. Now our next point of interest is the practical hints about the ion exchange chromatography. Now, as far as the practical hints of the ion exchange chromatography are concerned, here in case of the ion exchange chromatography, always you have to consider the pH and the pKa value. For the cation exchange chromatography, the pKa value, it should be lower than the 1.5 times, and for the anion exchanger it should be greater than the 1.5 times. So here in case of the sample pKa value and the appropriate eluent, what is the case? That is, we will see about the sample, then the pKa value related to the sample, and the next is the appropriate pH for the elution. So if you want to analyze the aliphatic amines, then the pKa is in the range of 9.5 to 11. Then for the pKa 9.5 to 11, the appropriate pH range is 11 to 12.5. This is the appropriate pH for the process of elution. Now, next is the aromatic amines. In case of aromatic amines, pKa, it is in the range of 4.5 to 7, and the appropriate pH, it is in the range of 6 to 8.5. Now the next category of the sample is the carboxylic acids. In this case, the pKa is nearly equal to the 5, and the appropriate elution, it is in the range of 3.5. Now, after the carboxylic acid, the next one is the phenols. For phenols, the pKa, it is in the range of 10, and the appropriate pH for the elution, it is 8.5. So this is about the different types of the samples, their pKa value and the respective pH with respect to the pKa value. Now the mobile phase pH, it is also very important. So we have to consider the pH of a mobile phase with respect to the acidic strength as well as the basic strength. So a pH value of 1.5 units higher than the pKa value in case of a cation exchanger, so that the separation can be carried out. And now in case of the anion exchanger, the pKa value 1.5 times less than the pH value. These are the necessary conditions. Now after this, the pH and pKa relationship and one more important thing, that is considering the pK and pH value for the analysis of the compounds by using the cation exchanger and the anion exchanger. The next is the effective buffering of a solution. All of you know that you cannot use only a single solvent as a mobile phase in case of HPLC. So always we will prefer to use 2 or 3 different types of a solvent together to use as a mobile phase. Hence, in this case, the effective buffering is also a very important step. So now in this case of effective buffering, that is along with the mobile phase, you are using the buffer solution. Now what is meant by the buffer solution? Buffer is a substance which maintains the change in pH even though a strong acid or strong alkali is added in it. So the effective buffering is also a very important step. Now effective buffering, it is caused if you want to use the pH typically in the range of pH 1.1 to 3.1 and next is in the range of 6.2 to 8.2. So effective buffering, it is possible in the range of 1.1 to 3.1 and 6.2 to 8.2. So the substances which are particularly carried out in analysis in the strong acid or strong base region, then you are using the effective buffering solution. Now along with this effective buffering, the next important thing is the high temperature. So most of the times the temperature used in case of the ion exchange chromatography, it is in the range of 60 to 80 degrees Celsius. So for the ion exchange chromatography, 60 to 80 degrees Celsius, this temperature is maintained, and with such a high temperature you can increase the temperature, and with such a high temperature you will obtain a better separation from the ion exchange chromatography. Now along with the pH, pKa, effective buffering and the high temperature, one more important substance is what about the mobile phase additive. So the next phenomena that we have to consider, it is about the mobile phase additive. So for the mobile phase additive, this mobile phase, it is a function of a sample's acid or sample's base, that is the pKa value. So in this case, that is mobile phase additive, the tailing is generally observed. So the tailing of a chromatogram in case of ion exchange chromatography, it is reduced by adding some substances. So how you can reduce the tailing? That is by adding the water miscible solvent. Here, the tailing of a mobile phase is reduced by using water miscible solvents. So in this case, the tailing of a mobile phase is reduced by using the water miscible solvent, and therefore the appropriate pH which is maintained, it is water miscible solvent means what? Water miscible and water immiscible, these are the two categories of the solvent which can be used. So water miscible, that means which are properly mixing in water, we call it as water miscible, and for water immiscible, that is the solvent which are not soluble in case of water, they are known as water immiscible type of a solvent. Okay, now after this process of tailing of a chromatogram, you can avoid it by using the mobile phase additive. So what are the small amount of the additives that we have added in the water miscible category of a solvent? That is a small amount of a fungicide, then along with it small amount of fungicide. What are the different fungicides which can be used? Such as the capronic acid, then after the capronic acid, next one is the phenyl mercury. After the phenyl mercury, the next is the sodium azide. Now after the sodium azide, next one is the carbon tetrachloride. Along with the carbon tetrachloride, one more important is the phenol. So these are the different fungicides which can be used for the prevention of the attack of the fungus or a bacteria in case of the ion exchange chromatography. Now that means what we can say, whenever you are doing the ion exchange chromatography practically, first you have to consider the type of a exchanger, that is whether you are going to use an anion exchanger or whether you are going to use the cation exchanger. Now after selecting the type of ion exchange, the next thing that is you have to consider the pH as well as the pKa value. After properly considering the pH and the pKa value, you have to consider the mobile phase, and in that mobile phase you have to properly select the water miscible category of a solvent. So water miscible solvent, this combination can be used in case of the mobile phase. Now after that, along with this, you have to also add some amount of the fungicides in case of the ion exchange chromatography. So apart from all this, the next is the counter ion and sample ion interaction. So the counter ion sample ion interaction, this is the most common type of interaction taking place in case of ion exchange chromatography. So for that, what we can consider, instead of using the common ions or the original ions, here you can prefer to use the another type of a ion. So what are this? That is, suppose R minus K plus reacting with a AgNO3, then it will form R minus Ag plus KNO3. Now apart from this, the next is R plus Cl minus plus NH4NO3 Along with that, it will form the R plus NH4 minus NO3 minus plus NH4Cl. So these are the common reactions or the common examples. If the new counter ion is not preferred, then instead of using the counter ion, you will use to prefer the H plus ion or the OH minus ion as a starting point. So in case of H plus and OH minus ion, what are the reactions taking place? So the next thing is R minus K plus HNO3, then it will form the R minus into H plus KNO3. Now suppose the next reaction is R plus Cl minus, and if you are using the NaOH, then in that case R plus OH minus plus NaCl. Okay, so these are the reactions where instead of using the counter ions, you will prefer to use the H plus ions and the OH minus ion. H plus ion in case of the cation exchanger and the OH minus ion in case of the anion exchanger. Now after this, you can also use a solution which is containing the counter ion, that is which is having the cationic or anionic nature, and the equilibrium is obtained. So for that, what are the reactions for them? That is, suppose R minus and H plus Li plus OH minus, then it will give you the R minus and Li plus H2O. Now after this, the next is suppose R plus and OH minus, then R plus OH minus and ClO4 minus. Okay, in this case R plus ClO4 minus plus H2O. So these are the reactions where the new counter ions, they are directly pumped through the column, and the possible reactions obtained are these. They may be in the cationic form or they may be in the anionic form. So this is about all the practical hints of the ion exchange chromatography. Now the next important point is what are the applications of ion exchange chromatography in HPLC methods. So in case of the applications, all the lanthanides, they are separated within the 30 minutes by using the ion exchange chromatography. So the first application is the separation of the lanthanides. For the analysis of all types of the lanthanides, the ion exchange chromatography is used. All types of the lanthanides can be analyzed within 30 minutes by using the ion exchange chromatography. Now the second one is the elution. Elution, it invariably follows the order. It invariably follows the order with a decreasing atomic mass. Now, along with this, it is also having a most important application in the field of biology. So, what is the biological application of this? So it is used for the analysis of the DNA and RNA. So the DNA and RNA which is present in the nucleotides, so for the analysis of for the separation of the DNA and RNA, it is used. Along with the separation of DNA and RNA, this lanthanides, this ion exchange chromatography, it is used for the analysis of 22 different types of the nucleotides. So this is all about the different applications of the ion exchange chromatography. Main application is the separation of lanthanide, another one is the separation of DNA and RNA, and another one is the analysis of 22 different types of nucleotide. So this is all about the ion exchange chromatography topic from the HPLC methods. Thank you.